Hello student, welcome to our lesson today. We are going to continue with the determination of refractive index, but in this case, we are going to look at the refraction through successive media. Now consider a ray of light that is traveling through multiple layers of transparent media whose boundaries are parallel to each other as shown in this diagram. We have a ray that is coming from air, then through medium 2, through medium 3, and then back to air. Now at the first interface, that is interface 1 and 2, you find that the refractive index of medium 2 with respect to medium 1 will be equal to sine I over sine R1. Then at the interface 2 and 3, this part, you'll get that the refractive index of medium 3 with respect to medium 2 will be sine R1 over sine R2. Multiplying these two equations, you get the refractive index of medium 2 with respect to medium 1 multiplied by refractive index of medium 3 with respect to medium 2 will be the sine I over sine R multiplied by sine R over sine R2. These two terms are common, so they cancel one another. And when they cancel, you are left with the sine I over sine R2. Then from there, at the interface 3 and 1, that is, if you want to get now the refractive index of medium 1 with respect to medium 3, it will be sine R2 over sine I, which implies that the refractive index of medium 3 with respect to medium 1, it will be the reciprocal of this. Remember from the previous lessons, we have seen that if you want to get this part, you get the reciprocal of this one. Therefore, it will be sine I over sine R2. If you look at this term and this term, that is equation 1 and equation 2, they are similar. Therefore, it implies that the refractive index of medium 3 with respect to medium 1 is equals to the product of these two. That is n, or the refractive index of medium 2 with respect to 1 multiplied by the refractive index of medium 3 with respect to medium 2. Note that this 2 is the same as 3 minus 1. Therefore, for k successive media arranged with boundaries parallel, the refractive index of k with respect to 1 will be the product of all the refractive indices until you get the refractive index of k with respect to k minus 1. This is our conclusion. Then from there, we have an example here. The refractive index of medium, or the refractive index of water, is 4 over 3, and that of glass is 3 over 2. Calculate the refractive index of glass with respect to water. We proceed as follows. The refractive index of glass with respect to water will be the refractive index of air with respect to water multiplied by the refractive index of glass with respect to air. Remember, these terms are similar, and the first one here and the last one is here. Therefore, because we are given the values, if you remember, for you to get the refractive index of air with respect to water, you need to get the reciprocal. And therefore, for you to get the refractive index of water with respect to air, you just get the reciprocal of 4 over 3. Therefore, the refractive index of glass with respect to water will be the multiplication of these two terms. So, 1 over 4 over 3 will be the same as 3 over 4. And then here we have 3 over 2. So, by multiplying the 2, you get that it is 1.2125. That is, you multiply and you divide. It is 1.125. That will be the refractive index of glass with respect to water. Then we move to second example. A ray of light travels from air through multiple layers of transparent media, 1, 2, and 3, whose boundaries are parallel as shown in this diagram. You are given the angles and you are given the rays. So you are supposed to calculate the angle theta, this value, the refractive index of medium 2, the speed of light in medium 1, and the refractive index of medium 3 with respect to medium 1. We proceed as follows. we are going to look at the same diagram here on this slide. So for the first one, we are supposed to get the value of theta 1. So we can use this formula where we say that n1 sine theta 1 is equals to n2 sine theta 2. So now we are getting the refractive index of air sine theta in air is equals to n1 sine theta 1. So the sine of theta in air is 35. The refractive index of air is 1. We have seen earlier. So it will be 1 sine theta 35, which is equals to 1.5 sine theta. Now to get the value of sine theta, you can divide through by 1.5. And when you divide, you get that it is 0.38. Therefore, to get the value of theta, it will be sine inverse of this value. So when you get the sine inverse, or you key in the sine inverse of this in your calculator, you get that the theta is 22.48 degrees. Then the second question was asking about the refractive index of medium 2. And the refractive index of medium 2 is this value n2. So again, we apply the same formula. n1 sine theta 1 is equals to n2 sine theta 2. Then we substitute the values. We have n1 as 1.5, theta, this one, because this one is we call them the alternating angles. It is the same. So this is theta, this is theta. So 1.5 sine 22.48 is equals to n2 sine 27. Again, you can be able to see that the angle of refraction here will be 27 because this angle and this angle are the same. So what is left as unknown is n2. So we can make it the subject of the formula by dividing through by sine 27. So 1.5 sine 22.48 degrees divided by sine 27 will give you 1.263. Remember, you have to key in your calculator and make sure that you put the brackets before you divide. Then from there, we proceed to question number C, where you are supposed to get the speed of light in medium 1. Now, we know this relationship that sine theta A over sine theta 1 is equals to VA over V1, where VA is the velocity of light in air and V1 is the velocity of light in medium 1. So we have theta 1 or theta in air, which is 35. We have found theta in this diagram, that is angle of refraction, as 22.48. So sine 35 divided by sine 22.48 is equals to the velocity of light in air, which is 3.0 times 10 to the power 8 divided by V1. And the V1 is the value that we are looking for. So we can make it the subject of the formula by cross multiplying and then dividing through by sine 35. So when you cross multiply, you have sine 22.48 times 3.0 times 10 to the power 8 divided by sine 35 degrees. Again, you key in these terms in the numerator in your calculator, ensuring that they are inside the bracket, and then you divide by sine 35. And when you do so, you'll find that the velocity V1 is equals to 2.0 times 10 to the power 8 meters per second. Then from there, we proceed to part D, where we are supposed to get the refractive index of medium 3 with respect to medium 1. We proceed as follows. We want the refractive index of medium 3 with respect to medium 1, which will be given by the product of refractive index of medium 2 with respect to 1 multiplied by the refractive index of medium 3 with respect to medium 2. And for us to get the refractive index of medium 2 with respect to 1, again we go back to the definition, which is now the sine of I divided by the sine of R. And I is 22.48 and R is 27. Then when you want to get the refractive index of medium 3 with respect to medium 2, again you come to this boundary. The I is 27, R is 25. So this value will be sine 27 divided by sine 25. And when you multiply, whatever you are going to get now will give you the refractive index of medium 3 with respect to medium 1. So this term is 0.84 and this term is 1.07, When you multiply, you get that the refractive index of medium 3 with respect to medium 1 is 0.9022. Remember, all the calculated value should be corrected to 4 significant figures. So if you write less, again, you try to find that you are penalized. Then from there, we move to the refractive index in terms of real and apparent depth. Now, when an object is underwater or under glass block, it appears nearer the surface than it actually is. And this happens when you view normally or when you are almost viewing it normally. You will find that that object appears to be closer to the surface. Now, this is due to refraction of light. And remember we said that the refraction of light is due to the change of velocity as light travels from one medium to the other. Now, the real depth is the actual depth of the object in the medium, while the apparent depth is the virtual depth of the object in the medium, or the depth in which now the object appears to be. It's not real, that is why we are calling it the virtual depth. The difference between the real depth and the apparent depth, we call it the vertical displacement, as you can see in this diagram. We have that the object is touching the bottom of our beaker. Therefore, the real depth will be from the bottom up to where we have the surface of water. But now that object is appearing to be here. So from here to here is what we are calling the apparent depth. Now the difference between now the real and the apparent is what we are calling the vertical displacement. Now, refractive indices of materials can be expressed in terms of real and apparent depths. And by definition, all we find that the refractive index n is given by the real depth over apparent depth. This formula only applies when the object is viewed normally. That is what you are supposed to note, that that object is appearing to be nearer the surface when it is viewed normally. Then from there, we move to an example. A coin in a glass jar filled with water appears to be 24.0 centimeters from the surface of water. Calculate 1, the height of water in the jar, given that the refractive index of water is 4/3. Then part 2, get the vertical displacement. Now we proceed as follows. By definition, the refractive index n is equals to the real depth over apparent depth. Now we are given the refractive index as 4/3, and we want to get the real depth. So this is what we are looking for. So we write the real depth, but the apparent depth is given as 24. Now to get real depth, we multiply through by 24. And by so doing, if you multiply by 3 here, you will get 8 here. So 4 times 8, you get 32. This now is the real depth. Now, and this is now the height of water in the jar. To get the vertical displacement, this is given by the real depth minus the apparent depth. And this one you just need to subtract. That is that 2 minus 24, you get that the vertical displacement is 8 centimeters. Now, when you plot a graph for real depth against apparent depth, the values gives you a straight line through the origin. And if you get the gradient, you find that the gradient will be the change in real depth over the change in apparent depth, which will give you the refractive index of that material. Then from there we have the assignment. Again, the assignment are just testing what we have just covered. So don't panic, be confident, and approach it with a positive attitude. So thank you, and let us meet in our next lesson.